Hello and welcome to Property Matters. I'm Stephen Galpin and today we're going to be carrying on our discussion about solar power. Joining me to fill us in with all the details is Wenyan Sharp, Marketing Director of Solax Power UK. Welcome.
Thank you.
And joining Wenyan is Emma Dutton, Training Manager of Solax. Again, experts in renewable technology. Welcome to you.
Thank you for having us.
Right, well, in the first programme, we discussed at length the application of solar power and indeed other alternatives for getting more economical power to our houses. Today, I want to talk a little bit about use in commercial premises. Now, one of the things that occurs to me is that if we are being driven by the sunshine, although as you explained in the first programme, we don't need so much sunshine now for the solar panels, how could I be sure as an industrialist that my machinery is going to have the consistency of power that it needs to make sure that my production lines don't stop during a day? Now, who's going to answer that one?
So the first thing that the installer will do is work out what your load is, what your usage is, and what the highest pull of power from the grid would be for each piece of equipment. So then they'd work out how many solar panels you can get on your roof. You'd need an inverter to convert that energy back to AC power to supply your machines. If there wasn't enough power, then you'll still be drawing from the grid. There's possibly, you'd possibly always draw from the grid with a commercial property, depending on the size of your roof, for example. You might use that much equipment and be pulling that much energy that the solar panels just can't generate that much. So you'd use half, maybe 45% from the solar panels and maybe use the rest from the grid. Or you could possibly use 70% from the solar panels and then 30% from the grid.
Okay, right, I get that principle. So a little bit like in the residential properties where you were talking about drawing power at off-peak times, putting it into a battery and then drawing it down into your home for use at a different time. I kind of understand the matching of the two efficiencies, if you like. But what's the unit that makes that choice? What reads as to what's coming off the roof and what's coming from the grid?
So you'd have a smart meter fitted. So before you install any equipment, your installer you should already know what your bills are, so you can see what you're using from the electricity companies, and then it will be down to the installer to work out how much electricity they can get from the solar panels on the roof to then be able to supply your commercial building and your equipment that you've got in there.
Well, I appreciate that, but is that a set calculation that's put into something that controls that? I'm trying to get to what controls it.
That I'm not sure of, to be honest.
Right.
You'd have to, as I say, it's all down to calculation, what the bills are over a set amount of time, working out what the load is of each appliance or each piece of equipment for a manufacturer.
Okay, so it's probably me being
a little bit more difficult.
Well, look, it's me being a bit simple, really. What I was trying to get at was, so, okay, let's say that your system is set up to take 30% from the grid, 70% from the roof. And then all of a sudden, today I've got 10 machines running, not 5. Yes. Is there something that adjusts that balance, or would I have to call my installer in and say, I need the balance adjusting?
No, so again, it all depends on the sunshine, really, the daylight, what you've got. Obviously, we live in the UK, so we've not always you're not going to have the same days, not going to produce the same amount of energy from the roof. So, like I said, there's a possibility that you're always going to be pulling something from the grid, no matter what. One day you might be only using 2 machines. Another day you've got a big order in and you've got to put your 5 machines on. Your solar panels or the equipment can't make you more energy to supply that extra equipment, so you'd be pulling more from the grid in that case.
Okay, got you. Okay, that's good. So when we're looking at some of our industry to make these conversions, which are obviously good for the environment and good for, I suppose, the running costs of the factory too, again, where does your introduction come from, Wenyan? Where does it come from? Do you have factories approaching you directly? Do they approach their sort of electricity suppliers who might recommend coming your way?
Well, usually these manufacturers, they use energy broker, don't they? So energy broker, they will give them this sort of ideas, you know, to saving their costs. It's all about saving costs for business, you know, because so much energy they use. Then these energy broker, they were working with installers or distributors, then to introduce them to solar power or battery storage systems.
Right, okay. And how successful are you being in attracting these people wanting to convert? Are we on a roll with it? Is it gaining momentum every day, or is it still a bit of a struggle?
These days, because cost them so much, these manufacturers, they're very proactive, looking for savings now. And also we do like exhibitions. Like next week we're going to County Durham. There's a big manufacturing exhibition to do with construction, to do with saving costs for businesses. So we trying to attend the different exhibitions to educate people, to showcase our products, so people understand where they can get these products from and how we can help them to saving their costs.
Okay. Again, in the first program, we talked about the resistance of some developers who are notoriously famous in this country for not wanting to get involved with innovation and new ideas. They prefer just to stick to the old ways are best, as they say. What's the main either question or criticism, or in fact resistance, that you get from commercial factory owners or industry to not do this work?
A lot of it is cost, or like we was just discussing, not knowing if the energy converted from the roof is going to be enough to supply the equipment, or to even supply just the general basics of the sockets and the lighting. So they'll say, well, what's the point of spending all of that money to put all of that on the roof, battery storage, inverters, when we could spend that somewhere else? So it is a bit hard work to kind of convince them to say, well, look, over time you are going to be saving money because your bills are just going to go up and up and up anyway. But it would be good if the government could give companies and homeowners more of an incentive to install renewable products.
Yes. I mean, I can see the difficulty with the argument, because it at the point of your interest in doing a sort of conversion, it's going to be very difficult to really pin down the factual cost. I mean, you shared with us your savings and in fact income from it that you've achieved with converting your home. But with a factory, it is a lot more complex, isn't it? You're going to have areas in the factory that are not producing sort of physical goods, perhaps warehousing or packing or one thing or another. Their requirements are going to be a lot less than the engineering section, aren't they? So it's quite a big job to go into a factory and do this. Is that something you do, or do you employ specific consultants to go into a factory and help them decide?
So that's the installer's job. So we don't install ourselves. We don't promote any single installer. We do have installers on our website that have been on the training, so that so when they've done the training, they'll be on our website. They can be premium installers, platinum installers, and then businesses can go on our website. They can have a look on the list of installers. They'll know that they've been and done our training, so that they're competent in fitting our kit. And then it's down to the installer then to sit and discuss with the customers what their requirements are, what type of equipment they've got, how many solar panels they've got on the roof, if that solar power is going to be able to cover all of their energy usage. If they've got excess power, then they don't want to be sending that back to the grid if they're not going to be getting anything for it. So they'll need to work out how much battery storage they'll actually need to put that surplus power in, so that they can use it at a later date. Most factories nowadays are 24-hour running, so that excess power that they've saved in the daytime can be used later on at night time to lower the cost of what they use.
That really is quite innovative, isn't it?
Yeah.
Yeah, I like that. Okay, well look, we're going to go to a commercial break now. And after the break, I think what I'd like to do is talk to you a little bit about the actual equipment that you supply. I know you've been talking about inverters and converters and batteries. And I think I need to know a little bit more about what they are and what their functions are, and I'm sure our viewers will sympathise with my position on that. So anyway, let's go to the break. Join me after the break and I'll be talking to Wenyan and Emma further on the subject of solar power. Hello and welcome back to Pot of Property Matters. I'm joined by Wenyan Sharp and Emma Dutton, both of Solax Power. Now, ladies, I thank you so much for coming in and talking to us about this subject. I found it absolutely fascinating, and the one thing it's doing for practically everybody that's watching or potentially watching is saving them money. And we're also at the same time looking at saving the climate too. So it's all win-win, isn't it, really? But although you've been kind enough to us enlighten us on the systems and the ups and the downs of the products and how disruptive or not disruptive it's going to be to have it, you have talked a little bit technically for us on some of the products that you provide. And I think I owe it to our viewers to ask for an explanation about those products, and let's go into that a little bit more deeply now. So the first thing, we've talked about the panels, we've talked about them not being supplied directly from you, but you obviously approve certain stuff to work with your equipment. We've talked about the panels on the roofs having a sort of 25-year life as an average, and also that they've been made in a much more effective way now, in so much as they don't need so much sunlight. Great, we understand that. That's pretty straightforward. Where we start getting into hot water is all the wires from those panels then go into something you're calling an inverter.
Yes.
So tell me what an inverter is.
So an inverter, or a converter as you want to call it, is a piece of equipment that will, so your solar panels make DC power, which is kind of the same as what's in your car battery, for example, but at a lot higher voltage. So the inverter will change that DC power into AC power, which is what your washing machine uses, your kettle uses, all use AC power. So the inverter will change the DC into AC power, and it will push it back down the cables into the property for whatever you're using at that point in time. If there's any extra, then obviously it normally goes back to the grid. So in that case, you'd be working out, let's just say that you've had your solar panels installed, you've had your inverter installed. 3 months later, you realise that you're sending half of that power back down the grid. You'd get back in touch with your installer and you'd say, I want to be saving this energy to be able to use it at a later date. The installer will then come in and they will talk to you what you want. So you've got a couple of options. You can have an AC charger, AC coupled unit, which then has another piece of equipment which has the battery connected to it. Then that will see the excess energy that's leaving, going back to your energy supplier. It will take that energy, convert it back to DC to put it in your batteries to save at a later date. And then when you come home later on, it can change it back into the AC and use it for whenever you've put your kettle on, your washing machine on. Then you've got your hybrid inverters, which will allow you to use that energy if you're going to lose the grid. So I live in a little village up in the Midlands. We lose the grid quite a bit. So I always need to have some kind of backup power. So a hybrid inverter will allow you to have backup power and be able to use the energy that's in your battery when you've lost the grid. So you can kind of become your own little mini substation, to speak.
Okay. And again, I'm going to ask you a question I've asked you before. What decides that switch? So you've got your power coming into your inverter. Yeah. It can either go to DC battery power, yeah, or it can go to AC living power.
Yeah.
Yeah?
Yeah.
What makes the switch?
So the inverter does the switch for you. So that has to change. The energy that you're making on the roof is always DC no matter what. So you have to change it back to AC. If you're out all day, then that energy that's changed from your DC to your AC will be pushed back to the grid, because you're only going to really have on your washing machine, your fridge, your fridge freezer. Maybe you've left your TV on standby. So that energy will be used before anything goes back to the grid. So if you're out all day, really you need to be considering battery storage to be able to save that energy, because you're not going to get the same amount of money from your energy supplier as you would be when you're buying it back. So in my opinion, you'd be better to save it in a battery storage system.
Better to save it.
Yeah.
Okay, well, let's move on then to the battery. What does this look like? Is it how big is it? Let's talk for an average house.
So for an average house, let's just say that you've got a two-person, well, you got your mum and dad, you've got 3 kids. You're going to be looking at, you're probably going to want somewhere between 5 and 10 kilowatts of battery storage, but that will depend on what you've got on your roof and if you've got a cheap tariff to be able to store any energy in. So you could have a 5 kilowatt battery, 5.8 kilowatt battery. Then you're probably looking at about this width and maybe about this high. You've got smaller batteries that start from 3 kilowatts.
Probably like a sort of air conditioning unit,
Yeah,
that sort of
something
size.
half the size of that really, yeah.
Okay,
Yeah.
good. And that would go outside, would it?
Ideally outside nowadays, because as I say, you've got the PAS regulations, the 63100. So yeah, outside. A lot of our batteries, for example, have got heating elements in. So during the winter time, the batteries get cold. They're not going to be as efficient as they normally would, like your mobile phone. Your mobile phone goes cold, it goes flat.
Or your car.
Yes. Your electric car goes flat in, well, it's not very efficient in the winter. So our batteries have got heating function in so that you can enable it during the winter months, and your battery will work a lot more efficient than other manufacturers do.
Okay. I'm just a bit loath to pin you down on this, but I think I need to ask. So this sort of battery that would be a suitable size for a 2 or 3 bedroom home, what sort of cost would that be?
I don't do sales, I'm just the engineer, and I don't like to get into sales because otherwise I'll be getting in trouble.
Come on then, let's hear it.
Well, as a manufacturer, we don't really advertise, how much, because we have to go through our sales channel.
But from a retail point of view, what sort of price would you expect a distributor to be quoting, just roughly?
Let's say if a 3-bedroom house have 8 panels with a battery system, inverter, these days installed, you're looking at around £7,000.
Yeah,
8,000 pounds.
Well, it doesn't sound an awful lot to me, really. And do you do a calculation of sort of recouping that capital
The
cost?
installer will do that for you, your ROI, yeah, your installer will do that for you. On average, I'd say that you could probably make your money back in 5-8 years at the most. But again, once you've got your battery storage system in, you'd be a little bit more savvy. You know what, you switch all your lights off, you don't put anything on standby, make sure that you're utilising that energy efficiently. As time goes on, your electricity prices are only going to go up, so you're going to be able to recoup that money back sooner than...
Do you think that's the way we're going, just on the economy? Do you think our energy prices are going to continue rising?
I think so. Everything's going up, isn't it? It's not like it's going to come back down, or even if it does come back down a little bit, it's not going to drop significantly enough for people to say, oh yeah, I've got loads more money in my pocket, let's go out spending. It's kind of...
I do get quite concerned about this, because we have pundits sort of saying things like, we've enjoyed cheap food for too long. We've enjoyed cheap money for too long.
I don't know where he's been getting it from.
Well, but I mean, we have got interest rates that have gone up sort of 300-400% now from where they were a couple of years ago. There's no question that food costs have gone through the roof. Now, whether that equates to energy costs, transportation costs, things, I just don't know. But it does seem to me that you're in an industry that can really help the economy, not just in terms of climate change and carbon emissions, but can be of genuine use to families and to factories and to business owners, taking down the costs of energy. That's at best, but if not at best, putting them in control of their energy, putting them in control of what they draw down from either a national grid or their own energy sources. So I think you're in a sterling business there, I really do.
Also, this is actually, as a country, you know, I believe we're also helping with the national grid structure as well. You know, they are struggle at the moment. Like in the winter, you see the light, you know, flips because not have enough electricity supply. So if people, you know, start have own battery storage, solar panel, that help taking off, you know, from the grid.
Yes.
Yeah, that's
I mean, I can also, I mean, I can also see a situation where you're providing the opportunity for sort of self-reliance, really. I mean, we often see, don't we, in the winter when we have storms and things, especially in the north of England and perhaps Scotland, where the weather is, shall we say, a little more wild.
Yeah.
You see pylons down, you hear stories of people without electricity for weeks on end while they're waiting for repairs. But actually, there are ways that this could give self-sufficiency, aren't there?
Well, that's it, yeah. So especially if you've got a battery storage system,
Yeah.
you're saving your energy. Our systems as well can work completely off-grid. So in that case, if you had lost the power for a couple of days, for example, as long as you've got the sunshine, you could add generator to your system to give you that extra bit of power as well. Then, yeah, you could easily sustain yourself.
All right. Well, ladies, I'm going to say thank you very much for coming in and doing these programmes. I'm sure our viewers will both find it interesting and perhaps thought-stimulating, because I think you really are doing a smashing job. So, Wenyan Sharp, Marketing Director of Solax Power, and Emma Dutton, Training Manager, thank you both very much, and we look forward to talking to you again. Thank you.
Thank you.
Thank you.
That's all we have time for today, so join me again on the next Property Matters.